MICON, the mobile all-weather anti-aircraft missile system, is a product of Contraves, Zurich. Several well-known Swiss companies have also had a share in the realization of this system in conjunction with Contraves Italiana, Rome. Contraves has gained great experience in the production of military and civilian equipment, particularly in the fields of anti-aircraft defense and aerospace technology. The electronic optical theodolites, designed to track flight paths and trajectories, are being used on a variety of firing ranges throughout the world. The wire-guided anti-tank missile is an example of a Contraves missile production program. A highly successful product of the firm is the radar fire control equipment Contraves. This is the radar set in a model designed for warships. The fire control system for controlling conventional anti-aircraft guns has been successfully introduced in many armies of the free world. In space research, Contraves has a share in several programs, for example by participating in the realization of the ESRO-1 satellite. The mobile missile system MICON is the ultimate product in Contraves' anti-aircraft missile field. It is designed to combat aircraft of the Mach II type, flying near a maximum altitude of 22,000 meters, or at low altitudes, and at ranges from 3 to 35 kilometers. Apart from the launchers, the MICON battery comprises the direction finders, the monopulse guiding radar, the computing and command units. Computations relative to the missile, the target, and the battery equipment are performed in the computing unit. The command unit accommodates the battery officer's desk, an econorama system which projects on a screen the target's flight path and the missile's performance coverage, and thus allows optimized firing. The target operator console, the two missile operator consoles. An operational tactical battery comprises 4 twin launchers, 2 direction finders, 3 power supplies, 1 monopulse guiding radar, 1 command unit, and 1 computing unit. 3 such tactical batteries form a defense group and are connected by a data link to an early warning and coordinating group center comprising 1 power supply, 1 early warning surveillance radar, 1 command and coordination center. The MICON missile comprises 3 main self-contained and interchangeable sections, ensuring great ease of maintenance, separate storage of the nose cone with the electronic and hydraulic equipments, the warhead, and the solid fuel rocket motor. Mounting and dismounting of rudders and wings is easily performed by a quick lock system. In the missile's nose cone, there is an infrared proximity fuse. Autopilot and responder block. The hydraulic servo control for the rudders and the auxiliary generator. Power and hydraulic supply generated by means of a gas turbine. Computer and amplifiers for servo drives. The attitude gyroscopes, providing high mechanical accuracy. The warhead, located between the nose cone and the solid fuel rocket motor, is of the conventional fragmenting type with high destructive power. Behind the solid fuel rocket motor, we see the ejection nozzle. Each of the missile subunits is subjected to very severe environmental tests, such as climatic, vibration, and acceleration tests. Here, the missile's electronic section is being subjected to acceleration tests on a centrifugal machine. Additional environmental tests are also performed on the complete operational missile, such as these tests on a vibration machine. Once the factory tests and checkouts are completed, the missile is ready for launching. The preliminary trials during the development of the MICON weapon system were performed on the missile firing range in Sardinia. The presence of operators and engineers, necessary in the preliminary trial stages, in no way contradicts the fact that the operational concept of this weapon system is based on extensive automation. The high maneuverability of the missile made it possible to apply the command beam rider principle based on monopulse differential radar. The principle is as follows. Let us consider a twin launcher, a direction finder, and the monopulse guiding radar. The monopulse radar detects and automatically tracks the target. The direction finder guides the starting missile into the narrow main beam of the moving monopulse radar, which takes over the guidance of the missile with high accuracy until the target is destroyed. The acquisition and tracking features of the monopulse radar permit the engagement of targets flying at very high altitudes as well as low-flying aircraft. Let us look at the main steps required for practice firing on a target aircraft. The finishing touch, the rudders are being fitted to the missile. Here the missile is equipped with a parachute recovery system instead of a warhead. Then the missile is placed on the launcher. The antenna of the direction finder is pointed towards the missile. We are now witnessing the takeoff of the target, a Beechcraft KDB-1. The target aircraft is remote controlled and its flight is checked on the strength of radar data projected by a panorama on the guidance screen. target tracking by means of the measuring base theodolite. The target is seen on the firing axis. The countdown is beginning. The recorders are starting before the end of the countdown and the firing. Flight towards the radar beam axis. Target aircraft enters the field of vision. Missile reaches the line of sight and watch the point of impact. Now! Here is the same missile shot as seen in the monopulse guiding radar axis. The target aircraft is located in the crosshairs of the radar telescope. The missile's recording flight path, given by the tracking theodolite films, enables the miss distance to be determined. In this case, it is less than 5 meters. With a warhead, this would mean a hit. In order to prove the efficiency of the MICON weapon system, a real demonstration firing on a CT-20 target aircraft has recently been carried out at the Landes testing range in France. The launcher is being emplaced by its own hydraulic system. The launcher is automatically leveled on its supports. Thanks to an appropriate loading vehicle, the missiles are easily and quickly placed on the launcher, as shown here. The launcher is then ready for firing. This missile, whose loading is being finalized, is going to be fired presently. The fire control officer is at his desk. The monopulse guiding radar is locked on the transonic target aircraft CT-20. The launcher points the missile towards the target. The fire control officer starts the countdown. The CT-20 target is approaching the launching zone of the missile. The direction finder is pointing at the launcher. Fire control officer arms the missile and initiates the firing. For this firing, the miss distance between the missile and target is less than 3 meters. Here is a slow motion picture of the missile start from the launcher. With MICON, Contraves continues its advance in the field of anti-aircraft defense.